In this next standard, we're going to learn how to graph inequalities and how to solve graphing inequalities. The term you need to know is a half plane, because you already know what an inequality is. A half plane is the solution to a linear inequality. The portion of the coordinate plane that lies on one side of a line called the boundary. Here's an example of a half plane. As you can tell, all of this is shaded in. Any of these coordinates can be solutions to that inequality. You may also notice that the line is solid. We'll get back to that in a few minutes. A linear inequality is similar to a linear equation. The difference is that instead of an equal symbol, equal sign, an inequality contains one of the four inequality symbols. Less than or equal to, greater than or equal to, less than, greater than. It's important to note that a linear inequality is not a function. For example, for the linear inequality y is greater than x, both 1 and 5 are possible values for y when x equals 0. Since there are multiple outputs, y values, for one input, x value, the linear inequality is not a function because the input can have multiple outputs. Going back to functions, an input can only have one output. You can, however, use the concept of a function to help you solve inequalities. If you replace the inequality symbol in a linear inequality with an equal sign, you get a related linear equation. For example, y is greater than 3x plus 2 is a linear inequality. We can rewrite that as y equals 3x plus 2, and it is its related linear inequality. Recall that you think of y equals 3x plus 2 as y equals f of x, with f of x equals 3x plus 2. The solutions of a linear function can be graphed as a line on the coordinate plane. The solution, what is shaded, is a half plane. Here are the rules for graphing. To graph a linear inequality in the coordinate plane, graph its related equation in order to find the boundary line. If the symbol is less than or greater than, draw a dashed line. Points on the boundary lines are not solutions. Just like in 6th grade when you graphed x is greater than 3, x cannot equal 3. So we left 3 open when we graphed the inequality. Same concept as here. Anything on that line is not equivalent to x, so it has to be dashed. If the symbol is less than or equal to or greater than or equal to, draw a solid line. Points on the boundary line here are solutions. They can equal it because of the equal symbol underneath the inequality. Then shade a region on one side of the boundary line. Put the inequality in slope-intercept form to determine where to shade. It has to be in slope-intercept form so that you can shade it and graph the inequality. If the inequality has the y is less than mx plus b, or y is less than or equal to mx plus b, shade below the line. This is extremely important. If the inequality has the y is greater than mx plus b, or y is greater than or equal to mx plus b, shade above the line.